everyone, welcome to the study of numerical analysis. You are given this question whereby you are told this side is 15 centimeter, that is signed opposite to C, and this other side is 6 centimeter, and you are told the change, the error in A is 1 millimeter, which is equivalent to 0.1 centimeter, and the error in C is 2 millimeter, which is equivalent to 0.2 centimeter. So the question is, you determine the error which is obtained in calculating A. Here. In calculating A. So we are going to apply the trigonometric ratio, whereby we know that tan of A will be given by the opposite, which is small a, divided by the adjacent. The adjacent is small c, the part which is opposite. Then, from there, we differentiate this equation partially with respect to A. So when you differentiate tan, it will be sec squared A, partial of A with respect to small a. When you differentiate A, it is 1 over C. C is constant with respect to A. Then we make use of this trigonometric, or before then, we divide by sec squared A in both sides to obtain this one. And from there, we make use of this trigonometric identity, whereby we know that from differential calculus, sec squared of A is the same as 1 plus tan squared of A. Whereby now we substitute, instead of tan squared A, we substitute it with A squared over C squared. And of course, we can LCM where is C. C divided by 1 is 1. 1 multiplied by 1 is C squared plus A squared. Then from there, we substitute here. Instead of sec squared A, we substitute it with C squared plus A squared over C squared. So when we do that, we are going to obtain C squared over C bracket C squared plus A squared, because in this part here, we are dividing, so we take reciprocal of this part here, which will be C squared over C squared plus A squared, as indicated here. One of the C's will cancel out, and in the numerator, we will be left with C squared divided by C squared plus A squared. So we have now found partial of capital A with respect to small a. Then we also obtain partial of A with respect to C. When you differentiate tan A, the result is sec squared A, partial of A with respect to C. When you differentiate C, 1 over C, the result is negative or 1 over C squared by power rule. Then from there, you divide both sides by sec squared of A. And when you do that, also you make use of the identity up there. This identity, whereby we have found out that sec squared A is the same as 1 plus tan squared A. So making use of that identity up there, we realize that partial of A with respect to C is the same as A divided by negative A divided by C squared into bracket sec squared A. Then we substitute sec squared A is the same as 1 plus tan squared A, and tan squared A is the same as C squared plus A divided by C squared. So when we substitute the value of sec squared A with C squared plus A squared over C squared, because we are dividing, we are going to obtain this. C squared will cancel out, and we are going to be left with minus A squared minus A divided by A squared plus C squared. Then we make use of the error in A, which is obtained by small change in A, partial of A with respect to A, modulus plus error in C, partial of A with respect to C. We substitute. We were given that partial of A is 0.1, and we are given that and we have obtained that partial of A with respect to A is given by up there. It is sort of be given by C. Our C is 15 divided by C squared. C squared is 15. 15 squared is 225. A squared 5 plus that 6. The result is 261 modulus plus partial of C is 0.2 multiplied by partial of A with respect to C. The result is here negative A. The value of A is 6 divided by A squared. A squared is 6 squared, which is that 6. C squared is 15. 56 plus 225. It is 261 modulus. Then this is the same. 0.1 times 1 times 15 is 1.5 divided by 261 plus. This is modulus, means you can ignore the negative. It is 0.2 times 6, it is 1.2 divided by 261. When you simplify, you are going to obtain the following. Of this, the result will be 3/290, and when you write it in terms of decimal places, you are going to obtain 0.01024. So thanks so much for taking your time to study with me on how to tackle these questions on error in numerical values. For more such learning, kindly tune on to my YouTube channel so that we may learn together on how to deal with errors in numerical questions for engineers and other people who learn applied mathematics, which is applicable in real life. I see you in the next presentation. Remember to subscribe to this channel so that you don't miss a single video which I upload for us every day. Bye bye. See you then.